All right, let's take a look at the project. It has some questions that maybe don't quite apply to this section. They think they got in the wrong section, but we'll still go through and do them. Okay, so again, I've changed the numbers a little bit, so make sure you use the numbers in your actual question. I'm just going to go and show you the process that you would go through. It says the diagram shows the gears of a bicycle. By pedaling, you turn the large gear through a 60-degree angle. AD is 8 inches and BC is 5 inches. So let's label that. So AD is 8 inches. The diameter of that circle is 8. BC is 5. So the diameter of this circle over here is 5. Okay. The length of the chain between the two gears is 25 inches. Answer each of the following questions. Question number 1. How far, where are we at? How far does the chain move around the circumference of the gear to the nearest tenth of an inch? Now, what they just said up here is that when you pedal, okay, the large gear moves 60 degrees. Okay, so let's make an example here. We have, say we had this angle here, and it's 60 degrees. They want to know how far does this move? How far is this? What's the length of this chain on the arc? Now, what that is called is arc length, and you may have to refer back to your notes for the formula for arc length. The arc length is a piece of a circle. Okay, it's not the full circle, it's part of the distance. So what we do is we take the formula for circumference all the way around the circle, which is pi times the diameter, and we multiplied that by the fraction of the circle we have. And we do that using the full circle would be 360 degrees. On top here we put the arc that we're looking at, just the section we have. So if we fill in our information here to find our arc length, pi times the diameter. What's the diameter of the circle? Well, the radius, we know here AD is 8, so that's halfway across the circle. All the way across the circle would be twice that. Okay, so my diameter is 2 times 8, or 16. So I fill that in, pi times my diameter of 16 times the arc. The arc was 60 degrees. It said it made a 60-degree turn out of the full 360s on the gear. And now we just take out our calculator and calculate that. Okay, so to do this you would do pi times 16 times 60, and then that fraction, to take care of that, you just divide by 360 there. Okay, so let's do that. Pi, use the button on your calculator, times 16 times 60, and then divide by 360. When I do that, I get 8 point, did it ask me to round to the nearest tenth? 8.37, which rounds to 4. So in this case, 8.4 inches is the distance that it turned that gear. Okay, so that's the amount of the chain that it moved along the gear. Our next question said, as the chain moves, it turns the small gear. If you use the distance you calculated in the previous question, through what angle does the small gear turn to the nearest degree? So this is turning our question around backwards. We don't know the angle. We want to know what angle did it turn the little gear. It's going to turn it a larger than the big gear, right? Because it's going to turn the little one further. So let's take a look. Well, let's say the chain turned at the same time, and we had this angle here. What do we know? We know from our last answer that the gear is going to turn the chain 8.7. So this time we know the arc length is 8.7. We want to know what's the degree of our angle there. So I'm going to draw that over here because it's kind of over on the edge. So here's the information we have. We have a circle, this small gear. We know its radius is 5. And we know we're turning the chain 8.7 inches. We want to know what's the measure of the angle here. Again, we're going to use that formula for arc length. Okay, same formula. We're just going to evaluate it a little differently. So again, the arc length is equal to pi times the diameter times our arc divided by 360. Okay, let's put in the information we know. The arc length we know this time is 8.7. We figured that out. That's how far the chain is going to move. And if it moves 8.7 on the big, it's going to move 8.7 on the small. Okay, equals pi times the diameter. What's the diameter of our small circle? Well, our radius from our given information was 5. 2 times 5 gives me a diameter all the way across of 10. I don't know my arc right here. That's my x. And then I still divide by 360. Well, let's solve this. So let's slowly undo this problem. Well, the first thing I'm going to do is I don't want to divide by 360 here. So I'm going to do the opposite, multiply by 360. As long as I do that same thing on the other side, it's okay. So I'm going to take 8.7 times 360. And when I do, I get 3,132 equals pi times 10 times x. Next, I'm going to do pi times 10. Okay, because that will make it a little more simplified. So I get 3,132 equals 31.4159 is where I'm going to cut that off x. I'm still solving for x. It's multiplied by 31.4159 right now. So to solve, I'm going to do the opposite and divide. Okay, so we take 3,132 and divide by 31.4159. When I do, I get x equals 99, what does it say, to the nearest degree? I get 99.69, which 99.6 to the nearest degree would round up to 100. So for the numbers I used in this question, that angle in the center is 100 degrees. So it's going, while it turned the big wheel 60 degrees, it's going to turn the little wheel 100 degrees. So that's the process you would use to solve those two project questions.